Okay, so this is the 9.1 population and sample. So, guys, today we're just going to learn, we're starting the statistics unit. The statistics unit has 4 sections. No worries on after these 4 days. On Friday, we will do a brief test on the statistics unit, and then we will go through and after that, we will go through and give you the full statistics unit test, and then we will start our review. Remember, the review for the exam, you need to make sure that you do come, depending on what class period you're in. If you're in second period, you have a specific time next week for the exam review. And if you're in third period, you also have a specific time for the exam review. Okay, so make sure that you do make yourself available and that you're there next week. Okay, so that'll be a very important time as we'll go over Desmos and how to go through the exam and how to get through some of your answers as well. Okay, so first of all, the population, that's the first thing here. A population is the entire group of objects that are being studied, or it could be a collection of all outcomes, responses, measurements, or counts that we're interested in. So a population is all. That's the big thing. It's all of the possible things that we're looking at. And a parameter is a measure or count of the entire population. So it's just a measure or counting. A population parameter might be the average of something, but it's talking about the entire population. So when you see the word parameter, you know that that is the entire population. A sample is a subset of the population. So it's a small group of the population, and that sample comes from a statistic. So a statistic talks about the sample. So the statistic is a measure, count, sample. So if you're confused, if you're talking about a population, the whole population, like of Lincolnton High School, then it's called a parameter if you're talking about something from the whole population. If you're just using a sample, so maybe you just sampled 20 students and you're talking about those, then what you're talking about is called a statistic. So P for population and S for sample. So why would you use a sample instead of a population? So obviously using a sample is quicker, it's more cost effective, and it can be just as accurate sometimes as the population. So getting the entire population could take a very, very long time because it's hard to track down people and hard to get everybody. So a lot of times a sample is chosen because it's quicker, more cost effective, and could be just as accurate as the population. So I'm going to start to move down here. Number 4, so a recent survey by the alumni of a major university indicated that the average salary of $8,500 of its 250,000 graduates was $123,000. Is this a parameter or a statistic? This is a statistic because it is the average salary of the 8,500. It's not out of the all 250,000 graduates. It's just out of that sample of 8,500. So it's a measure from the sample. Number 5, a survey of 976 American households found 32% of the households own 2 cars. Identify the population and the sample. So the sample is the 976 American households that were included in the study. So the sample is what we actually study. And then the population would be all American households. So we're looking at all American households. We chose 976 of those and found that 32% own 2 cars. Okay, so for 6 through 8, identify whether it is a population or a sample. Number 6 is the age of a few randomly selected participants in a study about a race of runners. That would definitely be a sample. Number 7 is the annual salary of each full-time teacher in a study about Phoenix High School. That would be a population because you're talking about each teacher in the high school. Number 8, a survey of 750 Georgia homeowners in a study about all of Georgia's homeowners. That would be a sample because we got the 750 out of all of them. For 9 through 11, identify each of the following numerical values as either population or sample. So 9, of a company's employees, the opinion of just those that were there on time one morning about what they thought of a new training program. That would be a sample. So it's not all the company's employees. It's just the employees that were there on time one morning. Number 10, in a study about a small company of 25 employees, the range of their employees' salaries. Well, that would be a population because you've got all 25 employees in your company. Number 11, in a study about the value of American homes in 2012, the average decrease of all the homes sold in Gwinnett. So that's only in one city out of all the American homes. So that's just a sample of all American homes. So we go to number 12. The second page for you guys is the types of samples. So there are different types of samples that you really need to know. 5 really important ones. The first one is called a simple random sample. A simple random sample can sometimes be referred to as just SRS. So if you see the letters SRS, you know that means a simple random sample. It is a sampling method where each member of the population has an equal chance of being selected to be in the sample. Usually a sampling frame is used where each member is listed and then assigned a number, and then numbers are randomly chosen. For instance, everybody's number or name might be put in a hat. You might use a random number generator and just pick numbers, but everybody has an equal chance is the big thing in a simple random sample. The next type of sample is a stratified sample. It's where you divide your population into at least 2 groups, and then some members are randomly selected from each group. So for instance, if I divide the class into who sits on the left side and who sits on the right side, then I have stratified it. I've divided it into groups, and then I will randomly choose 2 people from the left side and 2 people from the right side. Okay. Next is a cluster sample. In this, you divide your population into groups, and then all the members of the groups are selected. So let's say I take the seminar room is full, and let's say I divide it into 3 groups, the left side, the middle, and the right side. And then I pick either the left, middle, or right randomly. Let's say I pick the right, and that means I then have to sample all the people from the right. So that's the difference because that's a cluster. In a stratified sample, if I split them into groups, then I still randomly select people from each group. In a cluster sample, if I split them into groups, then I actually randomly select all the people from just one group. And next is a systematic sample. So you have a system. For instance, if all the people are in line at the cafeteria, think of all those little people there as the cafeteria, I'm choosing every 4th person in line. If you look, I'd be circling. I could say that's my system, to choose every 4th person that gets in line at the cafeteria. And lastly is a convenience sample, and that's when you sample members from the population that are readily available or convenient. So like if I want to sample people from Lincoln High School, but instead of going around the school, I just look at my classroom and say, oh, there's some people right here. I'm just going to sample them. Or, oh, there's some Facebook friends that are online. I'm just going to ask them. So you just do things that are really easy or convenient to you. So, which sampling technique is used here in 17 through 21? 17, there are 250 7th graders and 300 8th graders at generic middle school. We asked 45 7th graders and we asked 50 8th graders how many siblings they have to compare the 2 groups. So that is called a stratified sample because we have split them up into 7th and 8th graders and we have randomly selected 45 from the 7th graders and 50 from the 8th graders. Number 18, I ask all freshmen, no sophomores, no juniors, and then all seniors if they prefer vanilla or cherry Coke. These 4 groups are my only 4 groups to create a study of what should be in the vending machines. That is a cluster sample. So I split them up into groups, freshmen, sophomore, junior, seniors, and then I've chosen some of those groups. In this case, I chose freshmen and seniors and selected all of those to be in my sample. Number 19, I ask everyone in my 5th period class who has more than one computer at home in a study about all of my students for the year. So if I want to know about all the students, but I only choose the people in my 5th period class that are like right beside me, that are easy to be selected, that's a convenient sample. Those aren't good because you don't get a good representation of everybody. Number 20, I collect data from every 15th student on the list of this entire school population. So if you get every 15th student, you have a system in place. That's a systematic sample. And then number 21, after using a random number table to generate 2-digit numbers, I decide on 10 people to choose from the population. So I got a population, I got a random number table, everybody's numbers in there, and then I'd pick 10 to randomly choose from the population. So at the bottom here, ranking these samples from what would be the worst to the best. A convenient sample is the absolute worst type of sample. Okay. Stratified and cluster are okay. Systematic is a decent type of sample. And then just an SRS, a simple random sample, would be our easiest and maybe best type of sample. Okay. So again, remember, the key is to remember a convenient sample is one of the worst. A cluster sample also is one of the worst. Stratified, systematic, random, all those are okay because people are being randomly selected. And that's what we want in a sample. We want people to be randomly selected. We don't want people to just be chosen because they're close to you or they're easiest or they're your friend. We want them to be randomly chosen to be in here. So on Desmos, there's a couple questions for you to do on the assignment for today, pretty short, and that should take care of today's lesson. So thank you for listening, and I will talk to you tomorrow.